Okay, we're wrapping up 2.6 in Barnett, and I just wanted to do a specific video just for an application example here that is going to be common in our course. And it's actually right here. He says, how long will it take for money to double if compounded monthly at 4% interest? How long will it take money to double if compounded monthly at 4% interest? So this is compounded interest. Okay, problem. So let's break this down. How long will it take? That is a big hint that we're looking for t. We're trying to figure out the time it will take for our initial money, right? It doesn't say how much, it just says money. So p is just itself, money, p. To double means that my a, my future value, needs to be twice my initial installment, p. Again, notice we don't know what p is. We don't know how much money was invested here. Whatever it was, that amount is doubled in the future value a. And we're compounding monthly. Compounded monthly means that n is equal to 12. You have 12 compounding periods. The interest is 4%. That means r is 4%. But remember, we always write this as a decimal, 0.04. So with that being said, you have to remember the magic formula here that you have for future value. It's a equals p times 1 plus r over n to the power of nt. And all you have to do is just plug in now. Okay? So we're going to get twice p is equal to p times 1 plus 0.04 divided by 12 raised to the power of 12 times t. We're looking to solve for that t. So here on the next slide, that's exactly what we have. Here is our formula. And you'll see sometimes the book will use m instead of n in the formula. That's okay. And here it is plugged in. 2p equals p times 1 plus r over n raised to the power of nt. Now notice, you could divide both sides by p, and essentially that p will cancel itself out. So you're left with 2 equals 1 plus 0.04 over 12 raised to the 12t. Your textbook then in this solution evaluates what's in parentheses. My advice to you is to actually wait, to not do this yet. So my advice to you yet is to simplify the problem as much as you can and then deal with this parenthesis at the end. So what I'm going to do on the side here is do an alternative solution, and I'll skip this step of figuring out what 1 plus 0.04 over 12 is. Instead, I'm going to take the ln of both sides. So that's what you want to do. Take the natural logarithm of both sides. And you might be wondering to yourself, why do I want to do that? Well, because if you take the natural log on both sides, you can now use that property that you had of the logs that told you you can bring this power down and make it a multiple. So this would look like ln of 2 equals 12t times ln of 1 plus 0.04 over 12. Okay, and that brings us closer to isolating t by itself. In other words, solving for t. Because the next step would be to divide both sides by 12 times ln of 1 plus 0.04 over 12. Okay, divide both sides by 12 times ln of 1 plus 0.04 over 12. And that's, on the right hand side, going to give us t by itself, and on the left hand side is going to give us this ugly looking thing, which now would be a good idea to simplify with your calculator, so let's do that. Okay, so why don't we solve this on our calculator now? And on my calculator, I'm going to enter this expression here. ln of 2 divided by 12, ln of 1 plus 0.04 over 12. Let's do it. I'm going to start by opening a parenthesis for the numerator. The ln key is right here next to the 4 key, to the left of it. ln of 2, close parenthesis for natural log, close parenthesis for numerator, hit the division sign for the fraction bar, and open a new parenthesis for the denominator, where we had 12 times the log. You don't have to write the times, you could just put log. And just to show you again, we have log, natural log of 1 plus 0.04 over 12. So I entered log, so let me go back and hit natural log. Okay, and the expression is 1 plus 0.04 over 12. 1 plus, I open a parenthesis for the expression, 0.04 over 12. Close the parenthesis for that fraction, close the parenthesis for the expression, close the parenthesis for the denominator, hit enter, and that's how we get 17.36. which is exactly what we have on our slide here, 17.36. So it would take 17.36 years, right? That's the unit, for your amount of money to double under these circumstances, right? So that's exactly what we found here.